Okay, so here we go with scoping with blocks. Let's just kind of dive on in. This is, by the way, the sort of the classic way of thinking about scoping, and it ought to be pretty straightforward. It ought to be something that you kind of have your head around already from just doing Java or C++ or any of those languages. So the idea here is that a block is just any chunk of code in which you can define things, and then there's that, and defines the region of the program where those definitions actually apply. The classic, kind of extreme example would be ML here, where I actually have this let statement, right? And let basically says, let me make some definitions here. I'm going to make a value x, I'll assign it to be 1. I'll make a value y, which is the name of this value 2. And then the in explicitly right there, man, just calls out the scope of x and y. So once you start the let to the end, that's the scope. And then any other time x or y showed up anywhere else in the program, even right next door, wouldn't matter, okay? And that really is what the let is all about. Its only purpose is just to create this kind of scoping, so I can do things without any confusion, okay? Similarly in ML, we're going to look at a couple of different languages, but in ML, the function definition, right, the fun definition includes a block. So when I say fun cube, I've got a scope right there, okay? And if I have another thing that uses something similar, that's not the same scope, so I can reuse the name X. And then, even when I do, pattern matching, right, where I have like this function f, where I have that pattern, is a plus b, and that pattern, these things, each one of those is a separate block, okay? So I could say, on this first one, a and b, and then a plus b, and then over here I could just say b equals b. And the reason that I leave it a generally in ML is because it just makes sense. I've got a pattern that goes, I got an element, and then I don't care, right? That's a certain pattern. And then if I've got only one element and I use the same, variable name, but I don't, in a sense, you could say it's more confusing because I'm reusing a, but I'm reusing it in the same way to mean the same thing. So it's actually, ironically, paradoxically, not confusing, okay? Because it looks like the other stuff. So that's actually an interesting example where it's not the same scope, and I am going to use the same name, but I'm doing it because that's ML, and I want the pattern to match. When I have a match, once again, each one of those rules is a block. So here's a rule, there's another rule. This could have just as well used a on that one, okay? In Java, like other languages that are like C++, you can, you've got compound statements that are inside the brackets, right? I got the bracket and the bracket, and that creates a scope. If I declare a variable here, now, I cut my teeth on the C-like languages using C, so I've never in my life in Java or C++ ever honestly defined a variable right in the middle of a scope like that. And I don't exactly know why I haven't. I think it just always seems wrong to me. And so I just haven't dared. I don't know. I've seen it. It always just seemed non-intuitive to me. I'd rather just set them all up at the top like you have to do in C. But anyway, that's another example. If I say int C here, and then that guy plus equals C, and then right there I have another value called C that was defined up here somewhere, not the same C, okay? Different scope. I can also do nesting, where, let's go back to ML now. I've got the let, right? I declare a value called n, and then I have the in. Okay, then I've got another let. Okay, so the local scope prevails, okay? Hope that makes sense. The local scope, the smallest scope. So when I'm down here on this n, then this is my only scope right here. Let that value n equal to in n. This expression here is going to evaluate to 2 in this case, right? And then what I have out here is the same as if I'd written let val n equals 1 in 2 end, okay? These are not the same n. This guy doesn't even see that n because it already has an n, all right? So if, in other words, if I'm having a conversation with my brother Bob, and there's a neighbor named Bob, and somebody walks up and says, hey, Chuck, hey, Bob, I know they're not talking about the neighbor Bob. The closest one is the one that governs, okay? And that really, in a sense, is the classic block scope rule, okay? That's the classic. And, you know, here's kind of a, you know, definition. I'll try this and maybe it'll be too much. The scope of a definition is the block containing that definition, okay? From the point of the definition to the end of the block, minus the scopes of any redefinitions of the same name in interior blocks. That's a little bit, I don't know, it's a little bit too much maybe, but this might help to understand that a little bit better. Here we have the same example we used before, let val n equals 1. The scope of this definition is all of A, but not B, okay? So you'd have to remove this block, and then that would define the scope of this n. This guy, this n, is only within the scope here within B. I hope this makes sense. It's kind of a reasonably intuitive approach, I think, to think of it that way, right? I've got a local n, that's the one I think of first. Then if I didn't have an n, I would see this one. I don't even see that other n because I see this guy. He's the only n that I know about.